Hi everyone, my name is Mrs. Latham and I am one of the ninth grade math teachers here in Cranston. Today we're going to be looking at section 3.4, which is solving and graphing multi-step inequalities. You guys will need a notebook and pencil for today's lesson to take notes. And remember, this is a no calculator section. The learning objective for today is that students will be able to solve multi-step inequalities without a calculator and then graph those inequalities using a number line. So let's get started. When we are solving a multi-step inequality, there are 4 steps we will be using to help us solve. Keep in mind, we might not use all of these steps, and sometimes we'll have to use the steps more than once. So the first step is grouping symbols. In the example to the right of us, we actually have the distributive property, and that is considered one of our grouping symbols. Keep in mind, this is not the only grouping symbol, but it is one of the most common. In this, we are multiplying both the numbers inside the parentheses by -2, which ends up giving us negative 10x minus 8. Keep in mind, we do have another pretty common grouping symbol that I'm going to show you right now. It's normally in a 2-step. It is x plus 4 divided by 3. Keep in mind, there's no parentheses in it, but the division of 3 kind of groups them together like they're in parentheses. So if you're ever given a problem like this, maybe it's helpful to always put parentheses around them. For the second step, we are going to combine like terms. So if you notice, I have boxed the -8 and the 1. So we would have to combine those to get -7. Then we can add or subtract. In that example, I'm adding 7 on both sides. And then the last step would be to divide both sides by -10. I know it looks a little funny on my slideshow. I'm not quite sure what happened, but that's kind of how it downloaded onto my iPad. Then when we divide by -10 on both sides, we get the answer of -1. Now, please keep in mind and remember that when we're dividing or multiplying by a negative number on both sides of our inequality symbol, we have to flip our sign. Hence why it flipped when we went from that top row to the bottom row. Okay, so let's actually try some problems using this as an example. So in the first one, we have a 2-step. So what I'm going to do is I'm actually going to start off just by drawing my line down the middle. I have -10 plus n all divided by 4. So this is an example of grouping symbols. The -10 and the n are both being divided by 4, so we cannot separate them until the division of 4 is gone. So to remove the division of 4, we can actually multiply by 4 on both sides. When I multiply by 4 on the left, my 4's cancel, my -10 plus n come down, and so doesn't my greater than or equal to symbol. -1 times 4 gives us -4. The next step is to either add or subtract. So now what I'm going to do is add 10 on both sides. My 10s will cancel, my n will come down, and -4 plus 10 gives us the value 6. What I like to do when I'm graphing is to always put my answer in the middle of my line. So I'm going to put 6 in the middle, 7 and 8 on the right, and then 5 and 4 on the left. Now I have greater than or equal to symbol, so that tells me it needs to be a closed circle. And then I want to draw my arrow pointing towards all the numbers that are bigger than 6. Since 7 and 8 are larger than 6, I'm going to have my arrow pointing to the right. In the second example, this is an example of combining like terms. So what I notice here is I have 1/2 m plus m. Now we can treat the m by itself as 1m, or if you want to even go ahead, add another 1 underneath it to make it a fraction. Now to be able to add my 1/2 n to my 1m, I'm going to have to change my 1m to have a denominator of 2. So I'm actually going to multiply both the 1's by 2. And when I do that, I get my 1/2 m plus my 4/5, and then I end up getting plus 2/2 m. I can bring down my less than symbol, and then my 29/5. Okay. Now I can actually combine my two like terms since they have the same denominators. 1/2 plus 2/2 gives us 3/2 m, and I can bring down my 4/5. The next step after that is to add or subtract. So I'm going to subtract my 4/5 on both sides. Thankfully, my 29/5 and negative 4/5 have the same denominator, so I don't have to change anything. So we get, I'm going to write it off to the left a little bit here. My 3/2 m is less than 29 minus 4 gives us 25. 25 divided by 5 just gives us the value 5. So I'm going to write it just as 5. I won't leave it as a fraction. Then my last step here is to multiply by the reciprocal. So the reciprocal of 3/2 is 2/3. My 3's cross cancel, my 2's cross cancel, and we are left with m is less than 5 times 2 gives us the value 10, and then over 3. So we get 10/3 for this. What I'm going to do is I'm going to stick 10/3 in the middle here. If I go over 1 to the left, I get 9/3, which is the same thing as 3. And then I have 8/3. If I go to the right one, I have 11/3. And then if I go right one more, I get 12/3, which is the same thing as 4. Now it's not equal to, so that tells me I'm just going to have an open circle. And then I want to look at all the values smaller than 10/3, which is going to be all the values to the left. So I'm going to draw my arrow to the left. There we go. There's our solution. For the next two, we're going to be looking at the distributive property and variables on both sides. So I'm going to draw my line for the first one on the left. When I go to distribute my -2, I have to make sure I multiply it to both values inside the parentheses. So -2 times k gives us -2k. -2 times 7 gives us -14. And then we have our less than symbol, less than or equal to, and then -10. We do not have any like terms here, so I'm going to move on to adding and subtracting. I'm going to add 14 on both sides, and we're left with -2k is less than or equal to a +4. The last step here is to divide. So I'm going to divide everything by -2. My -2 cancel, and if you remember, when we're dividing by a negative, we have to flip our sign. So I'm going to get k is greater than or equal to 4 divided by -2 is -2. Again, I'm going to stick -2 in the middle, -1 and 0 to the right, -3 and -4 to the left. Now for this, I'm going to have a closed circle because it was equal to, and because k is bigger, I'm going to have my arrow pointing to the right. There we go. For the next one here, we have decimals. So we have to be super careful when we're solving this. This is an example where we actually have variables on both sides. So looking here, I cannot distribute. I have no grouping symbols. I cannot combine like terms, so we're going to go straight to adding and subtracting. What I'm going to do first is subtract my decimal of 0.96. When we're subtracting decimals, we have to make sure that our decimal points line up. When I do that, I cannot do 3 minus 6, so I am going to have to borrow from my 5, which gives me a 4, and a 13. 13 minus 6 gives me, I believe, 8. 14 minus 9 gives me 5. So I get 0.58 for that decimal, and I can bring down my 5.4x, my less than symbol, and then my 5.5. 5x. And again, those canceled right there. The next thing I need to do is add or subtract again. This is an example where we have to do that same step twice. So I'm going to subtract 5.4x and move it to the other side. Left side cancels, 0.58 is going to come down, and then I'm going to get the value of 0.1x. My last step here is to multiply or divide, and because we have 0.1 next to the x, I'm going to divide. That's going to cancel, and we're left with x and our less than symbol. Now, dividing with decimals, we will have to do long division for. I'm actually going to zoom in a little bit. That way I can do this out. So I have 0.1. This is my at the door. And then I also have my 0.58, which is in the house. Now, to be able to solve this, I actually have to move my decimal points over 1. So when I do that, it actually turns into 1 and then 5.8. Now, 1 goes into 5 times. And then we subtract and get 0. Then we bring down our 8. And then 1 goes into 8 times. And then we subtract and get 0. Now, when we do this, the only thing we have to make sure is that our decimal point ends up in the correct spot. So we're going to bring it straight up, and it's going to be in between the 5 and the 8. So our final answer here will be 5.8 is less than x. So I'm going to put my 5.8 in the middle, and it depends on how your math teacher wants you to number this. I'm just going to count up by my tens place. So I'm going to have 5.9 and 6, and then 5.7 and 5.6. I'm going to have an open circle on 5.8, and then I want all the values smaller than that, so my arrow is going to point to the left. Well, actually, I just made a mistake, right? If you notice, x is on the right-hand side. So we actually want x to be bigger than 5.8. I was reading that wrong, so I apologize. So we actually want it pointing to the right because x is actually greater than 5.8 is the smallest number. So we should not have any values smaller than that. There we go. There's our 2 answers. Now for these 2, I would like for you guys to try these on your own. See if you can solve for these and see what you get for an answer. It might not be like what we got on the last 4 examples. So if you would like, pause right now, see what you get for an answer, and then unpause to see what I get for an answer. So for this one, I'm going to draw my line down the middle. And I am actually going to zoom in on this problem because it is going to require a little bit of work with that fraction. So I do have parentheses, so I am going to distribute. I have my 2/3 times p, which gives me 2/3 p, and then 2/3 times -9/2. When I go to do that, I'm going to do 2 times -9 to get -18, and then 3 times 2 to get 6. Okay? Now, 18 divided by 6 actually gives us a value, so if you would like to reduce that, you can. And when we reduce that, we get the value 3. And then I can bring down everything else. Now, because there's variables on both sides here, I'm actually going to move my variables. I'm going to subtract 2/3 p on both sides. And I want you to notice something. The left side completely cancels. But the right side also completely cancels. 2/3 p minus 2/3 p, it cancels out, it goes away. My -3 gets brought down, and so does my greater than sign, and then 7. This is an example of no solution. We cannot have -3 is greater than 7. It's not possible. If you're in debt $3 and then you have $7, right? There's no way that those two things can be equal to each other. So this is a no solution. And what's great with a no solution is we don't have to graph anything. So you would leave your graph blank because we can't graph this. It's physically impossible. And there we go for that one. Then for the second one, we have infinitely many solutions as an example. So let's see what happens when we solve this. I'm going to draw my line down my middle. And then I'm going to distribute. I really want you guys to be careful with this. You are not going to do -4 minus 5 first. That is not following the steps of solving an inequality. An inequality. We have to distribute first. So we are going to take our -5 and distribute it. That -4 is only going to come down. We're not doing anything with it just yet. -5 times b is -5b, and then -5 times 6 is -30. And I'll bring everything else down. Then what we can do here is we can combine like terms. I have -4 and -30. I can add these together. When I add them together, we will get -34, and then I can bring down my -5b and everything else. The next thing I can do is add or subtract. I want to do my variables, so I'm going to actually add 5b to both sides. And just like the no solution example, the -5b's and the +5b's are going to completely cancel out both of them. And we will be left with -34 is greater than or equal to -38. Now, in this case, this is completely true. -34 is greater than -38. So this is an example of infinitely many solutions, also known as IMS. Depending on your teacher, they might also call this all real numbers. In any stance anyway, we have IMS. So in this case, when we would go to graph this, we would actually have a line that completely spans our entire number line. Because what that's saying is any number, no matter what it is true. It's going to work in the problem. I like to use the numbers that were given, so -38 through -34, but you don't have to use those. You could use technically any numbers, but I like to use what we're given. So I'm going to put those on here. Sometimes the numbers you're given won't match up. Like if you have 0 and -100 and it works out to IMS, like you're not going to be able to list all of them. But for this one, I can list them all out. And there we go. There's our graph for this one. So what's really key takeaway in this, you cannot graph no solution, but you can graph IMS. And that is it for today's lesson. If you have any questions, please reach out to your math teacher. And I hope this was helpful. I hope you guys have a good rest of your day. Thanks. Bye.